chemical equations, right? So we have chemical reactions. So we have divided this chapter into two types, okay, two parts. The first part is your chemical equation and balancing. The second part is type of chemical reactions. Now what happens here? In this chemical equation, we will be studying what is a chemical reaction, characteristics of chemical reaction, chemical equations, and then balanced chemical equation, okay. Next, coming to in types of chemical reaction, we have combination reactions, decomposition reaction, displacement reaction, double displacement reaction, exothermic and endothermic reaction, oxidation and reduction reactions, and lastly we will be talking about redox reaction, okay. So yes, now coming to the first thing, that is chemical equations and balancing. What is a chemical reaction? Okay, so it is a very simple thing. A chemical substance, okay, any substance when undergoes a reaction, okay, one chemical substance gets converted to another chemical substance. This type of process, this process is called as chemical reaction, okay. What is it? When a chemical substance gets converted to another chemical substance, means the new chemical substance is formed. It is completely having different properties, okay. These type of process are called as chemical reactions. Now, in the suppose how a chemical reaction is written, A gives you B, okay. A undergoes certain chemical processes and gets converted into B. So what is A called as? A is called as reactant and B is called as product, right? Okay. Now you can see one example here. Magnesium was there, oxygen was there, right? Now both of them combined undergo one chemical reaction to form your magnesium oxide. Now the properties of magnesium oxide is completely different from the properties of magnesium and oxygen, okay. So that is what is a chemical reaction, okay. As a compound undergoes certain changes to form another compound, and this product that is formed is completely different from the reactant, okay. Fine. Now, okay, so as I told you, you can download the link from our website. You can download the class PDFs. The link will be there in the description section. So you can see different subjects, maths, real numbers, so biology, life processes, okay, chemistry, physics, every subject notes you can download. You have to go to the link that is there in the description section of this video, okay. Fine. Now coming to characteristics of a chemical reaction. So how can, by just seeing, we can tell that whether a chemical reaction has happened or not, okay. So every process is not about chemical reaction. We need to have certain checkpoints, right? If these things are happening, then yes, chemical reaction has taken place, right? So what are that checklist that you need to check whether a chemical reaction has happened or not, right? That is what you need to know. The first thing is there should be a change in state. What is change in state? Okay, so now I'll tell you first of all, these are the different things. So if any one of these or more than one, okay, it is found, then we can say that the reaction has undergone a chemical reaction, okay. So now change in state, suppose your reactant is a solid and the product has become a I can say liquid, okay. So change in the state has taken place with, there should be some change in color, there should be some change in temperature, or there can be evolution of gas, okay. So if any of these changes takes place, okay, it can be more than one, it can be any one of them, okay. So generally we find more than one changes takes place generally, okay. So in that case we can say that chemical reaction has taken place, okay. Now coming to 1.3, that is chemical equation. So what do you mean by chemical equation? It is a symbolic way to represent a chemical reaction. Now see, for example, I say that magnesium reacts with oxygen to give you magnesium oxide. Magnesium reacts with oxygen to give magnesium oxide. So this one writing is very difficult, right? We need to write such big words, but yes, there is a simplified version of that. You can use symbols for this. So we know magnesium is Mg, oxygen O2, and magnesium oxide is MgO, right? So this is a chemical equation where the chemical reactions are written using the symbols and the formulas, okay. Now Now you see this reaction, we can say that this reaction is not balanced. Okay, I'll say that the reaction that I wrote is not balanced. Now a question may arise, then what is a balanced reaction? Very simple thing. A balanced reaction means that the number of atoms of each element, okay, suppose a reaction has 3 or 4 elements, it will be on the reactant side, it will be also on the product side, right? So the number of each element on the reactant side and on the product side should be equal. Now I'll show you how the previous reaction is not balanced. See, if you see on the, this is reactant side, right, and this is product side. So if you see on the reactant side, right, magnesium, how many atoms are there? 1. Oxygen, I can say oxygen is 2. And if you see on the product side, magnesium is 1, but if you see oxygen, it is also 1. But on the reactant side, oxygen is 2, here oxygen is 1. That means what? The number of atoms are not same, right? So that is a not balanced reaction. If the number of atoms on both sides of the reaction, that is on the reactant side and on the product side, is not same, then we say that the reaction is not balanced. Then what we should do? We need to balance the reactions, right? So now see how to balance the reaction. So we'll take this example. So this is your H2 reaction, okay? Okay, now we need to balance. So number of atoms of each element should be equal on the product and the reactant side. Okay, let us try this example and see whether we are able to, whether this reaction is balanced or not. If it is balanced, that is fine. If not, we will try to balance it. Okay, fine. Let us start now. See, the first step you need to do is you need to write the elements name, Fe, hydrogen and oxygen. This side 3, this side 3. There will be always the same reactants, same elements on the reactant side as well as on the product side. Now here it is reactant and here it is product. So you see Fe there is 1 and product side there is 3. Hydrogen 2 and hydrogen 2. Oxygen here 1 and here we have 4. Right? Okay. So now if I see that, first I can see that iron is not balanced. There is only 1 iron on the reactant side, whereas there is 3 irons on the product side. So I can make it 3Fe. Okay. Now if I see oxygen, here there is 4 oxygen, right? And here there is only 1 oxygen. So I can make it 4 here. Okay. Now if I make this one 4, I got hydrogen became 8 now, right? The reactant side hydrogen became 8 now. So this one also I should make it 8. So I will multiply 1, 4 here. Now if I see the final reaction, what I am getting? 3Fe, okay, plus 4 water gives me Fe3O4 plus 4H2. Okay. Now let us calculate the number of elements again. So we have Fe, we have hydrogen, we have oxygen, and then we have on the reactant side and we have on the product side. So there is iron, there are 3 on the reactant side and there is 3 on the product side. Hydrogen, if you see, there is 8 here, there is 8 here, right? Oxygen, if you see, there is 4 oxygen here and there is also 4 oxygen here, right? So you see now all the elements numbers are same on the reactant and product side, right? Then we can call it that this reaction is now balanced. Okay, fine. So let us move forward now. There is a question now. We'll be doing more practice of questions. Okay. So now, which of the following is the correct observation of the reaction in the above setup? So here one reaction is going on. Okay. What is the correct observation for that? Okay. Brown powder of magnesium oxide is formed. Can you see any brown powder? You can see it is written here white powder, right? So this is a wrong statement. Colorless gas which turns lime water milky is observed. So if you see colorless gas, anything that turns lime water milky is carbon dioxide, right? But we cannot find any evolution of gas here. So this statement is also wrong. Now magnesium ribbon burns with brilliant white light. So yes, if you can see here, when you are burning the magnesium, here there is a dazzling light is formed, right? A white light is visible to you. So yes, this statement is correct. Next, reddish brown gas with a smell of burning sulfur has evolved. That is also incorrect. The correct statement for this question is your option number C. Okay. Now moving forward to the next question. Okay, Rima took 5 ml of lead nitrate solution in a beaker. So let us imagine there is a beaker, okay, and you took lead nitrate on this, okay, and added approximately 4 ml of potassium iodide, Ki. Okay. Now, what would she observe? Okay. Now, if you will be studying this also, if we do the reaction PbNO3 plus Ki, okay, the product we will be getting is PbI2 plus KNO3. Okay. So, this one will react with this one and this one will react with this one. Okay. So, that is a double displacement reaction. Okay. We are going to cover that in detail also. So, now what you can see here, this PbI2 is yellow in color. Okay. Now, you might be asking, ma'am, how can we just know by seeing the reactions? So, dear, you have to remember certain colors. You also need to remember the products of the reactions. Okay. Now, there were thousands of reactions in the world, right? How to remember? So, you need to practice those examples, those questions which is there in your book. Okay. So, those reactions you must practice. Okay. So, that is why I can say that because we know this reaction is there in our book, we can say it is yellow in color. Okay. So, now the yellow precipitate was formed. The correct answer for this question will be option number B. Now, question number 3. So, now we will do balancing question. Okay. So, it is given SnO2 plus XH2. Okay, WSnO2 plus XH2 gives you YSN plus ZH2O. Okay, so you need to find for, okay, the question was we will find all W, X, Y and Z. Okay, we will find all, but the question has asked for W, X and Y only. Okay, fine. Let us see now. I will write the first elements. Here we have Sn, that is your tin, we have oxygen and we have hydrogen. Then I will make a table, reactant side how many elements are there, product side how many elements are there. So, reactant sides Sn is 1, product side now it is 1, oxygen it is 2 and this side it is 1, okay. Hydrogen here it is 2 and this side also 2, okay. So, now if I first see oxygen, we can balance the oxygen one first. So, I will get SnO2, okay, plus XH2. Okay, that gives me YSN plus H2O. Okay, fine. Now, if I balance this, first of all, I want to balance oxygen, so I can multiply a 2 here, right? So, I will write that, okay, 1 second. We will not take these numbers, we will solve and then we will answer. Okay, fine. So, yes. So, you can see here there is 2 oxygen and there is 1 oxygen. So, I can make it 2 oxygen, right. Now, the number of oxygen is balanced. Now, if I balancing that, you see the hydrogen has become 4 here. Hydrogen is 2 here. So, I can write 2 hydrogen, right. So, now if you see this is 1, this is 2 and this is 1, right. So, question has asked for W, X and Y. So, I can say W is equal to 1, X is equal to 2, okay, and then Y is equal to 1, 1, 2, 1. Correct answer is option number B. Okay. Okay, next question. What happens when the steam is passed over red hot iron? So, now we have come to 2 marker questions. Okay, I will be telling you how exactly you need to present the answer in the board examinations. Okay, this is a subjective question now. What happens when the steam is passed over the red hot iron? Write the equation. So, whenever a question is asked, if it is a 2 marker question, read the question and try to understand which part of the question carries mark. Okay, what part of the question carries mark here? 2 marker question. So, there is a one part that is write the equation. Okay. Now, is heating Fe to red hot a physical or a chemical change? Okay. So, this is writing a equation is 1 mark and this whether it is a physical or a chemical change, that is the second 2 marks, second mark you have to get. So, first we can write the equation. If Fe is passed through red hot iron, is passed over steam. Okay. So, I can write steam means water in the gas form. So, this will give me Fe3O4, okay, plus H2. Remember to balance the equations always. So, if I want to balance this, I will get 3 Fe, okay, and we have 4 oxygen and I will get 4 hydrogen. Right. So, this is the balanced equation. So, the first this mark if you write, you will be getting 1 mark. Okay, 1 mark teacher will put for you. Now, coming to is heating Fe to red hot, a physical or a chemical change. So now if you just heat it, okay, the color of that will become red hot, but the substance is not undergoing any chemical change, it is still iron, right? If you take a rod of iron, okay, and you start hitting it on one side, then will this substance will change to give you anything? It will still remain iron only. So there is no chemical change happening here. So is a physical change or chemical change? You will write this is a physical change. Okay, so students, it is very easy to score in science if you know how to write the answer. Just you need to mention that it is a physical change, then you will get 2 marks in this question very easily, right? Okay, now let us move to the next question. Okay, list any 2 observations when FeSO4 is heated in a dry test tube. Okay, so when you hit FeSO4, what happens? So you need not write this reaction, but whatever reactions I am discussing in this class, you note down all these reactions. Okay, for this question we just need to tell what are the changes observed, but we need to know what is the reaction happening. So when FeSO4, if you heat it, okay, this is the symbol for heat, we will get Fe2O3 plus SO2, okay, plus SO3. This is the reaction. For exam, this reaction is not required. You just need to write the changes. So the first change what happens is this FeSO4 is a green color compound. Okay, so you can write the green color changes to brown color. Okay, next you can write colorless gas is observed. Colorless gas. Okay, so if you are writing these 2 points, you will get 2 marks for this question easily. Okay, so this will carry 1 mark and this will carry 1 mark. Clear? Now let us move towards the next question. What is a balanced chemical equation? Give an example. This question has been asked previous years also. So that is very simple. First thing you need to write, again this is a 2-marker question. So you have to understand, writing the definition is 1 mark, giving an example is another mark. So first thing you need to write is a balanced chemical equation, a balanced chemical equation, okay, is an equation where the number of atoms of each element is same, number of atoms of each element is same on the reactant side, and on the product side. Okay, so you have to remember, first point you need to write the definition, okay, that is 1 mark. Second point you need to write the example, that is 1 mark. Okay, so we have written the definition, right? Now we need to write the example. You can write any example. So suppose I write CaCO3 decomposes to give you on heating CaO plus CO2. Okay, so you can see the number of atoms: 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygen, and then 3 oxygen. So the reaction is balanced here. Okay, fine. Now let us move towards the next question. Again we'll do some practice questions on balancing of equation. So balance the given chemical equations. So this is again a 2-mark question. If you balance this correctly, you will get 1 mark. If you balance this correctly, you will get 1 mark. Okay, so there is no thing like if you half balance, half not balance, you will get some mark, you will get 0. If you balance completely correctly, all the atoms are balanced, then only you will get 1 mark. Okay, there is no half marks in such type of questions. Okay, so yes, let us start balancing. We have FeSO4, that gives me Fe2O3. Okay, what are the products? SO2 plus SO3. Okay, let us first, what is our task? To note down the elements. We have Fe, S and oxygen. And what are the reactants and products? So reactants, Fe is 1, okay, product side Fe is 2. Reactant side sulfur is 1, product side sulfur is 2. Oxygen, reactant side it is 4, and here it is 3, 4, 5 plus 3, 8. Right? Okay. Now to balance it. So if you see, we have 2 Fe here, we have 1 Fe here, so I will make it 2 Fe. Okay. Now if I make it 2 Fe, now iron became 2, Okay, sulfur also became 2 and oxygen became 8. So automatically it got balanced here, right? The correct answer, the option balanced equation is this one, right? Very easy. Now let us go to the next one. You have Al, that is aluminium, plus copper chloride gives aluminium chloride plus copper. Okay. Now if I want to balance this reaction on the reactant side, what all things are there? Aluminium, copper and chlorine. So reactant side and product side. So reactant side I have 1 aluminium, 1 copper and 2 chlorine. So product side I have again 1 aluminium, 3 chlorine and 1 copper, right? So to balance it, you see only chlorine is not balanced, right? So what I can do, if I multiply 3 here, so what I'll get? 3 copper now. So this became 3 copper now. Okay. So now if this is I'm making 3, I'll make 3 also here. So this one will also become 3. Okay. Now when I make this one 3, so chlorine became how much here? 6. 3 into 2, 6 chlorine. So now my chlorine is 6. To make this one 6 chlorine, I can multiply a 2 here. So this one will become 6 chlorine, right? Now if you see aluminium, now if I multiply this one, aluminium has become 2. So I need to multiply 2 here. So I'll get 2 aluminium. 2, 3, 6, 2, 3 and 6. So what I can say? 2 aluminium plus 3 CuCl2 gives me 2 AlCl3, okay, plus 3 Cu. So now if you see 2 aluminium, 3 copper, 6 chlorine and then 6 chlorine. Okay. So the reaction is again balanced. Okay. Now next question, we are going to 3 markers question. Okay. So write a chemical reaction of the following changes with one example for each. Okay. So you need to give an example for each type of reaction where there is change of color, there is change of temperature, there is formation of precipitate. Okay. So first one, you can write any reaction, okay, change of color, any reaction. So if you take Fe, okay, plus CuSO4, then this CuSO4 is blue in color. Okay. Now after the reaction, what happens? We get FeSO4, okay, plus Cu, and this solution is brown in color. So there is a change in color, right? This can be the example of A. Next, change in temperature. Any neutralization reaction, if you write a reaction between an acid and a base, for example NaOH plus HCl, okay, so this will give you NaCl plus water, right? Here what happens, the temperature will be, and you will get the container in which you are doing the reaction, that container will become hot, right? That is because of what? Because of temperature, change in temperature. Next, third one, formation of precipitate. So if you take PbNO3 whole 2, okay, plus Ki, then we will get PbI2 plus KNO3. Okay, so this PbI2 is a yellow precipitate. Clear? So we can write other examples also, but if you can remember one example for each, that is enough to get. So you are writing 3 equations, 3 marks you will get. Okay. Now coming to the next question, write the chemical equations for the chemical reactions taking place here. Okay. So again, 3 reactions you write, 3 markers you will get. So iron reacts with steam. So this we have already written, Fe with H2O gas, steam, right? This is first reaction. We will get Fe3O4, okay, plus H2. So we get 3 Fe here, okay, and then we'll get 4, and then we will get 4, right, to balance it. Next one, magnesium reacts with dilute HCl. Okay, so this one, when a metal reacts with acid, we get salt and hydrogen gas, right? So again, salt I'll get MgCl2 plus H2, right? So now if I want to balance it, I can just make it 2 HCl. You need 1 magnesium, 2 hydrogen, 2 chlorine, and then 2 chlorine. Next, third one, copper is heated with air. Air means oxygen, okay? So when copper is heated with air, we get copper oxide. So to balance it, we can write it 2 2 here, right? 2 copper, oxygen, 2 oxygen. Fine. Okay. Now coming to again there's a reminder here, if you want these notes that you can directly download it from our website, the link will be there in the description section, so you can download it for all the classes that is going on. So we have maths and science classes. In science there will be physics, chemistry and bio classes, so you can download it from there. So please check the link, go to the link and then go to the website and then download the classes notes. Okay, fine. Next, coming to, we'll practice more 3-marker questions. Okay, now 2 gram of FeSO4 are heated in dry boiling tube. Okay, list any one observation, name the type of chemical reaction and write the chemical equation. Okay, so now if you see, again 3 points have been asked, 3-marker questions. You just need to write one observation. So I have already told you what is the observation here. Greenish color, okay, changes to brown color. Okay, this is the first point. Now second one, what you have to write? Name the type of chemical reaction. So first of all we need to write the chemical reaction. Okay, so FeSO4, okay, gives you Fe2O3, okay, plus SO2 plus SO3. So if I want to balance it, I'll get 2 Fe, then there is 8 oxygen, so 3, 3, 6, 7, 8. So this is the balanced reaction. Now you see a single compound is giving you many products here, right? A single compound when heated, this is a symbol used for heat. So when a single compound is heated, we are getting 3 different products formed here. So what we can say is this type of reaction, when a single compound breaks down to many other products, this is called a decomposition reaction. Okay, so what type of reaction is this? Decomposition reaction. Okay, so just you need to write these 3 points and you will get a 1 mark for here, 1 mark for here and 1 mark for here. Clear? Now one thing I want to tell, suppose in case you know these 2 and you don't know the reaction, then just do not forget to attempt A and B. If you have written correct, you will get 1 mark here. If you have written correct, you have get a 1 mark here. If you have written this, you will get correct here, right? So whatever you know, whichever answer you know, do not do not think that okay, I don't know 2 of these, I know only 1, let me leave it. Not like that. Whichever answer you know, you need to write down that. Okay, fine. Okay. Next we'll go to the second part of the chapter, that is types of reaction. Okay, so there are basically 4 types of reaction, that is combination reaction, decomposition, single replacement, double replacement and combustion. Combustion is again a type, you can say, of combination only, but the major characters or the major types of reactions are your combination, decomposition, single displacement, double displacement. Okay, now see, what is a combination reaction? When 2, suppose this is A, this is B, okay, these 2 have combined and formed a new product, we call it a combination reaction. Okay, next, decomposition reaction, when a compound was there, A and B was there, you gave some heat and A separated, B separated, 2 new products are formed. Okay, then it is called decomposition reaction. Now the single displacement reaction means what? There is A and there is BC. What happens now? A comes and replaces B here. Okay, and B goes out, so we get AC plus B. Are you getting? A is there, BC is one compound. A comes and replaces B, so B goes out, now A and C is formed, right? So these type of reactions are called as your single replacement reactions. Now coming to double displacement reactions, we have AB, we have CD. So A combines with C, B combines with D, or you can say any other, A combines with D, B combines with C. So one atom from here and one atom from here will combine, that is called as your double displacement reaction. Next, combustion reaction. Combustion reaction is any compound reacting with oxygen to give you carbon dioxide and water, and a lot of amount of heat is generated. Okay, fine. Now these are the examples, definitions. Combination reaction, you need to learn these definitions. Okay, so the first definition here is 2 or more compounds combine to form one compound. Decomposition, you can see A plus B gives you AB. The opposite of combination, a complex molecule breaks down to simpler ones. Okay, now coming to displacement, one element takes place of another element in the compound, right? A takes B and you get AC plus B. Double displacement, when a part of two ionic compounds is exchanged and makes two new components. So from here A and C have combined and B and D have combined to give you two new components. Okay, so these type of reactions are called as your double displacement reactions. Clear? Fine. Now we will discuss something. We just discussed what is decomposition reaction, right? Decomposition reaction means one single compound is there and then it breaks into smaller compounds, right? This is called decomposition reaction. Now to break this compound into smaller compounds, we have to give certain type of energy. Okay, so if you give electrical energy and you break a compound, that is called electrical decomposition. If you give light, and so if you give here electricity and break this compound, sorry, okay, so if you break this compound by giving electricity, okay, electricity you give and break this compound, okay, that case this decomposition will be called as electrical decomposition. Now you can break this compound by giving light also. If you give some light and the compound decomposes, we call it photochemical decomposition. And if you give heat, so here you need to give light, right? And here for thermal decomposition we need heat, right? So we can write one example of each from here. So if you see electrical decomposition, H2O, if you treat it with electrolysis or we say electricity, okay, we get H2 plus half O2. Okay. Photochemical decomposition, if you take AgI and give with light, okay, you get Ag plus I2. Okay, I can balance it like this. Thermal decomposition, if you take calcium carbonate and you heat it, you get calcium oxide plus CO2. So you have to remember one example of each type. Okay, this can be a 3-marker question. This can be a 3-mark question. Okay, so yes, you have to remember example of each type. Okay. Next, coming to another two types of reactions are there, exothermic and endothermic reactions. Now see, suppose I told you this exothermic reactions are those reactions where the heat is released. Okay, means heat is a product. That means heat is a product. Okay, now endothermic reactions means what? Where heat has to be given. Okay, so here heat has to be given. Heat is given. Okay, so I can say heat is given means heat is a reactant. Okay, so the reaction happens in presence of heat. Okay, now we can see example. If you see exothermic reaction, just now I told you combustion reaction if you do. Suppose for example CH4 plus O2 will give you CO2 plus H2O plus heat. Okay, so heat is produced in this reaction. Okay, the temperature will increase. Heat is produced in this reaction. So this is an example of exothermic reaction. Now another, all the neutralization reactions. So this is combustion. Okay, combustion reactions. Now another we have is your neutralization reaction. So if you have NaOH plus HCl, that will give you NaCl plus H2O. Okay, so NaOH plus HCl will give you NaCl plus H2O. Now this is also accompanied by heat. So this is an base, this is an acid, this is base, this is acid. So this is your neutralization reaction, right? Now endothermic reactions where heat is given to do the reaction. So this can be an example for this one can be thermal decomposition reactions. There can be other also, but thermal decomposition you can remember very easily. CaCO3, if you give some heat, you will get CaO plus CO2, right? FeSO4, if you give heat, you will get Fe2O3 plus SO2 plus SO3, right? So these are the examples of your exothermic and endothermic reactions. Okay, now coming to another type of reaction, that is oxidation, reduction and redox reactions. See, oxidation reaction means what? There are two definitions, that is addition of oxygen okay, or removal of hydrogen or loss of electrons. Okay, so these are the examples of oxidation reaction. So either there is addition of oxygen, or there is a removal of hydrogen, or there is a loss of electrons. Now for example, if I write Mg, okay, plus O2 gives MgO, right? Now what happens here, if you see which definition fits here? Addition of oxygen. To magnesium I added some oxygen to get this one. So what I can say here, that magnesium is oxidized. Magnesium is oxidized. Okay. Now if I talk about reduction reactions, okay. Now what is the definition of reduction reaction? Removal of oxygen, just the opposite of that, okay. Removal of oxygen, addition of hydrogen, or gain of electrons. Okay, these are the different definitions for reduction reaction. Now if we see an example for this one, suppose I take a reaction here, H2 plus F2 gives me 2HF, right? So to fluorine I have added hydrogen, right? So I can say that fluorine has and is reduced. Okay, fluorine is reduced. Now let us see what is a redox reaction. So from the word you can see there is made up of two words, reduction and oxidation. So what is a redox reaction? If reduction and oxidation, okay, occurs together, okay, then we call it as a redox reaction. Okay, now let us see an example for this one. If I write Fe2O3, okay, I'll write in this place. So if I have a reaction like this, Fe2O3, okay, plus CO gives Fe plus CO2. Okay, now see, if you have to compare from Fe to Fe, here to here, what has happened? If I see from here to here, from Fe2O3 oxygen has been removed, right? That means what? This reaction has undergone. So let me write it here, Fe plus CO2. Okay, I'll erase this one. Okay, now you see from Fe2O3 to Fe, what is the thing? Oxygen has been removed from here to here. That means if oxygen is removed, what is this? Addition. Removal of oxygen is what? Reduction, right? So I can say that from here to here there is reduction. Okay, now you see what has happened from CO to CO2. There was one oxygen here, there is two oxygen here. So addition of oxygen has taken place, right? So addition of oxygen is what? That is oxidation. Okay, now one very important thing you have to remember, that the species which undergoes reduction, okay, what I am saying, the species which undergoes reduction, okay, it behaves as an oxidizing agent. Remember this one, very important. What I am saying, species which undergoes reduction behaves as an oxidizing agent, and the species which undergoes oxidation will behave as a reducing agent. Okay, now let us see these examples again. Now magnesium is undergoing what? Oxidation. So magnesium will behave as a reducing agent. Okay, not reduction, it is behaving as a reducing agent. Now if you see fluorine is undergoing is reduction, so fluorine will behave as an oxidizing agent here. Okay, now if you see here, Fe2O3 is undergoing reduction, so Fe2O3 will behave as an oxidizing agent. Carbon is undergoing oxidation, so it will behave as a reducing agent. I hope this is clear, very very important. Species which undergoes oxidation behaves as a reducing agent, and the species which undergoes reduction behaves as an oxidizing agent, and the species which undergo reduction behaves as an oxidizing agent. I think I repeated once again. The species which undergoes reduction behaves oxidizing agent, species which undergoes oxidation behaves reducing agent. Okay, fine, we'll do questions from there also. Now let us see next question. Which of the following is an example of single displacement reaction? Okay, you tell me this one, is it any displacement reaction? No, I can see this is from one compound we are getting two compounds, so it is a decomposition reaction, right? So we can eliminate this one. Now if you say CO plus HCl, two things are combining, okay, then Ca and Cl will form H2 and O is formed. So I can say that it is a type of double displacement reaction, not a single displacement. Now if you see here, Fe and copper sulfate, Fe is coming here, copper is coming out, right? So these two are replaced. So yes, this is a single displacement reaction, right? The correct answer will be option number C here. Okay. Now next question, C6H12 O6 plus O2 gives CO2 plus H2O. So which type of reaction is there? O2 is added, oxygen is added, carbon dioxide and water is there. So this is a combustion reaction, right? So remember, in combustion reaction always heat will be produced, right? If heat is produced, then it is an exothermic reaction, right? Okay, next, okay, here some assertion reason questions are also there. Let us practice them. So reaction of quicklime, okay, with water is an exothermic reaction. Quicklime reacts vigorously with water, releasing a large amount of heat. Now, what is quicklime? Calcium oxide, right? So it reacts with water, okay, reacts with water to give you slack lime, okay, with a large amount of heat. Because heat is produced, it is an exothermic reaction, right? And yes, so assertion is correct, and releasing a large amount of heat, reason is also the correct explanation of assertion. The correct answer for this question will be option number A. Okay. Now going to the next question here, what is observed? Okay, we'll go to now 2 marker questions. What is observed when a solution of potassium iodide is added to a solution of lead nitrate taken in a test tube? What type of reaction is this? Again, what is observed, if you write, that is 1 mark. And if you write the reaction, what type of reaction is this? This is a 2nd mark. Okay. So first we'll write what is observed. So for that we need to know the reaction, right? So it is asking lead iodide, potassium iodide plus lead nitrate. I think we have written this reaction already before. So if these two will react, I will get PbI2 plus KNO3. You see in how many questions this reaction is asked, right? So this reaction is really very important reaction. Now this is a yellow precipitate. Okay. Now is writing this reaction the correct answer? No. What is the question asked? What is observed? What you are observing? You have just mixed 2 these things. You cannot see this reaction happening. What is your observation? The observation is yellow precipitate is formed. So if you write this reaction, answer is not, I cannot say it is exactly correct, it is somehow okay, but that is not the good answer. What should be your answer for this one? Answer, you should write what is the observation. The we can observe, or you can write we can observe yellow precipitate. We can observe yellow precipitate due to the formation of lead iodide. Okay. After this you need to write the reaction. Okay. If you write reaction, that is fine. If you do not write, that is also fine. But you need to, the answer here is, what is the answer? What exactly is the answer? Formation of yellow precipitate. Okay. If you write this one, you will get 1 mark. Now what type of reaction is this one? Now you see here, K is replacing here, I is replacing here. So this is a double displacement reaction. Double displacement reaction. Getting? Fine. So here you need to write what is the observation. If you write only reaction, that is not a very good answer for this one. Okay. Now next, why is respiration an exothermic reaction? So you should first write, though when the question is why is respiration an exothermic reaction, so first you need to write first point, what is an exothermic reaction? Okay. So exothermic reactions, again this is a 2 marker question. So exothermic reactions are those, so I will first write the scheme, then we will write the example. Okay. Wait. So first you need to write, first point should be definition of exothermic reactions. Okay. So that is heat is released. In those type of reactions where heat is released is called as exothermic reaction. This will give you 1 mark. Next you have to write which respiration takes place in the, what type of reaction takes place in, okay. Next you have to write what type of reaction takes place in respiration. Reaction in respiration. Okay. So if I write this one, okay, so respiration reaction is C6H12O6 plus O2 gives you CO2 plus H2O. Here you must mention heat, okay, because you are telling heat is produced. So after this you have to write conclusion. Conclusion is since heat is produced, in respiration, it is an exothermic reaction. Okay, getting? So like this the answer should be there. First of all, when they are asking this is why this is an exothermic reaction, first explain the examiner what is an exothermic reaction. Second point, write down why this is an exothermic reaction, and then you can write down the conclusion. So I will say this is not mandatory, okay, but yes, a presentation of answer will be good if you write the conclusion. Clear? Okay, now coming to question number 15. Identify the type of reactions and give one example of each. Okay, so now you see this is a 3-marker question. So identifying the type of reactions in A and B will be 1 mark. How this one? If you identify this one correctly, that is half mark, and here it is half mark, right? Half you will get. And giving one example of each, so this is +1, this is +1, right? You give one example, you get 1 mark, give one example, you will get 1 mark. That is how you will get 3 marks, okay? So you will write the answer like this, first one, okay? A is what? This is a single displacement reaction. So you can write down single displacement reaction. B is what? Double displacement reaction, right? So this one will give you half mark, this one will give you half mark. Next, examples. Okay, so examples for first one, single displacement reaction if you write. Okay, so just now you can write any examples. Okay, just now we wrote a reaction here, right? Yes, Fe plus CuSO4 I can write. Okay, so you can write down Fe plus CuSO4 gives you FeSO4 plus Cu, right? Similarly, the second one, that is double displacement reaction. Okay, so double displacement reaction you can write down lead nitrate plus Ki gives PbI2 plus KNO3. Right? If you write this one, you will get 1 mark, you will get 1 mark here. So total 3 marks you will get. Okay, fine. Now coming to next question, mark the chemical reaction is redox reaction, justify your answer. So you have to explain whether this is a redox reaction or not. If yes, why? If not, yes, you have to justify. What is the answer for this? The first point, 3 markers, so you should write the answer in 3 steps. First one is definition of redox reaction. Okay, this is 1 mark. Second point, you need to show which part is oxidation, what is oxidation, and third part you need to show which is reduction, right? So if you write in these 3 points, you will get 3 marks for this question. Okay, so first let us write the answer now. Okay, so the first one is definition of reduction. So definition you can write redox reactions. Okay, redox reactions are those reactions where oxidation, I am writing in little short form, you have to use the full words, okay, occurs, oxidation and reduction occurs simultaneously. Okay, now coming to this one, here if I see, now you see from MnO2 to MnCl2, what has been done? Oxygen has been removed, right? If you can see, oxygen has been removed from MnO2. Removal of oxygen is what? Reduction. So I can say that here to here is reduction, right? Now if you see H is there, right? So I can say from H what has happened? Chlorine has been removed and what? Oxygen has been added, right? Chlorine has been removed and oxygen has been added, or you can say that in chlorine, see, chlorine what is happening? From chlorine hydrogen has been removed. Okay, from chlorine hydrogen has been removed, so removal of hydrogen is what? Oxidation, right? So the second, this is my first point. Second point, what I need to write, in the given reaction, MnO2 is reduced as oxygen is removed. Okay, right? Second, third, this one you can write, HCl is oxidized as hydrogen is removed. Okay, now you need to write the conclusion here. What is the conclusion? Okay, here you can write the conclusion that since reduction and oxidation is taking place simultaneously, okay, it is a redox reaction. Getting? So this is the first, this one if you write, this will give you 1 mark, this is 1 mark, and then this is 1 mark. Okay, again conclusion is not mandatory, but yes, it is a way of writing the answers. Fine. Now going to the next question. Zn liberates hydrogen gas with HCl but copper does not. Why? So how to start this reaction? The question is saying that Zn liberates hydrogen gas with HCl. So first we can write the reaction. Zn plus HCl gives ZnCl2 plus hydrogen, right? And copper plus HCl, you can write no reaction. Why the question is asked? This is very simple. This is a 3-mark question, but the answer is very simple. First thing you need to write, zinc is more reactive than hydrogen and it can replace hydrogen from its salt, right? Second, you need to write copper is less reactive than hydrogen and hence it cannot displace hydrogen from its salt. Okay, so that is why next you can write lastly, one second, yeah, so next you can write that's why zinc produces H2 but not copper. Clear? So that is how you will get 1 mark each. This is 1 mark, this is 1 mark, and then this is 1 mark. Clear? Okay. Next, question number 18. Identify the oxidizing agent in the following. So remember, what is oxidizing agent? Species which undergoes reduction. Species which undergoes reduction behave as an oxidizing agent. Now, what are the definitions of reduction? Reductions are removal of oxygen or addition of hydrogen, right, or gain of electrons. Okay, these 3 definitions we need to check here. Okay, now if you see here H2O, what is happening? From we need to find oxidizing agent, so we need to find that species which is undergoing reduction. So if you see H2O to H2, right, so if you see oxygen is removed here, so I can write in A. Okay, so you can only, when this is asked identify, you need to just write water. This is just answer, but I am telling you for explanation that oxygen is removed. That means this species are undergoing reduction, so it will behave as an oxidizing agent. Now you can see here copper oxide to copper, again oxygen is removed, so this is will behave as an oxidizing agent. So I can write oxygen is removed, right? Next, if you see from V2O5 to vanadium, again here oxygen is removed, so this agent is oxidizing agent is V2O5. Okay, the reason is same. Clear? Okay, now going towards the next question, identify the reducing agent. So I told you species, okay, species which undergoes oxidation behaves as a reducing agent. Behaves as reducing agent. Now what is oxidation according to this? Oxidation means addition of oxygen, okay, or removal of hydrogen or loss of electrons, right? Now let us see from here. If you see we need to find what? Species which is undergoing oxidation, right? So NH3 to NO, what is happening? If you see NH3 to NO, hydrogen is removed, okay, and also oxidation is oxygen is added. So yes, here NH3 is undergoing oxidation, so it will behave as a reducing agent. So I can write both the definition, hydrogen is removed, okay, and also oxygen is added. Now coming to B, H2 plus O2 gives, sorry, one second, okay, this F is not there. H2 plus O2 gives you H2O. So now if you see for H2, oxygen is added to H2, oxygen is added to H2, right? So that is why H2 is undergoing oxidation and it is behaving as a reducing agent. So what I can write? Oxygen is added. Okay, now third one, Fe2O3 plus CO gives Fe plus CO2. Now if you see carbon, CO is there and CO2 it is becoming here, right? So oxygen is added to CO, right? If oxygen is added, it is undergoing oxidation and it will behave as a reducing agent. So I can write CO is a reducing agent. Why? Again oxygen is added. Getting? Okay, now we will go to one 5-marker question. Okay, so these type of questions are generally where A, B, C, D is given. This are your word problems. Okay, word problem. So first of all, to understand this type of questions, you need to draw a schematic diagram of the question. What is step 1? Draw a schematic diagram of the question. Schematic diagram. Okay, you need to approach this question in this way. Okay, now see, a metal nitrate A. So I'll read like a metal nitrate A. So what is A? A is metal nitrate. Okay, on heating, so when you heat A, okay, gives a yellowish brown color metal oxide. So we get a metal oxide, I get a metal oxide along with a brown gas B and a colorless, gives a yellowish brown color metal oxide along with brown gas B and a colorless gas C. So there is one metal oxide produced, okay, plus there is B and plus there is C. What is this B? There is one B is brown gas, okay, and this is colorless. C is colorless gas, brown gas and colorless gas. Now what is it saying? This compound metal oxide is a yellowish compound. Okay, fine. Okay, next coming an aqueous solution of A reaction with potassium iodide. So if A reacts with potassium iodide, okay, forms a yellow precipitate compound D. So this is D, which is a yellow precipitate. Okay, so like this you need to first draw a scheme of the question. Okay, next identify A, B, C, D. Also identify the types of reactions taking place. Okay, now metal present in A, this metal is used as an alloy which is used for soldering processes. Okay, now you see we have learned so many reactions and I told you that yellow precipitate was formed by PbI2, right? When this metal nitrate PbNO3, if so I can say that yellow precipitate with iodine, which I know is PbI2, right? This is the first thing we can derive, right? So this is PbI2. So if this is PbI2, then definitely this is PbNO3, right? This is PbNO3. Now brown gas, that is NO2, we know brown gas is NO2, colorless gas will be O2 and the metal oxide is lead oxide, right? So we have easily found A, B C and D. Now you might be thinking, ma'am, how quickly you are doing. So this you can do easily if you know all such reactions. Okay. Now they have also asked you to tell you identify the type of reaction. So if I say PbNO3 plus Ki, so this is a what? I am getting PbI2, that one element is and KNO3. So this is a double displacement reaction. Double displacement reaction. Okay, and this one, the decomposition is happening here, so I can write this is a decomposition reaction. Okay, so how are you going to write the answer? You just need to write these things, then you can mention A is this, B is this, C is this, D is this. This reaction is double decomposition, double displacement, and this is your decomposition reaction.